Now let's look at the second question. Now atoms with 2 electrons in their outermost shell can combine with atoms with 7 electrons in their outermost shell. Draw dot and cross diagram to show such a combination. Name the atoms and the compounds formed. Now 2 electrons in the outermost shell, that will be the group 2 element. An example of group 2 element would be magnesium. And then the other part of the question says 7 electrons in the outermost shell. So an example of element with 7 electrons in the outermost shell would be, for example, fluorine, group 7. So we can take magnesium and fluorine as the example. Now you have to name the atoms and the compounds formed. Draw dot and cross diagram to show such a combination. So you have to draw magnesium fluoride. Okay, so just draw the dot and cross diagram. Now the question doesn't say whether or not you have to draw only the outermost shell or I mean you have to draw only the valence electrons or all the electrons. So that means you have to draw everything, because there is no mention in the question that you need to draw only the valence electrons. So you have to draw everything. So magnesium, the number of electrons is the same with the number of protons, which is 12. So 12 means 282. Now 282 meaning that it has 2 valence electrons. So it would tend to lose these 2 valence electrons to become 2 positive. Okay, and then it would lose the 2 electron to fluorine, and fluorine is 27. So it gains, so 27, that means it needs 1 valence electron. But now there are 2 valence electrons from magnesium, so you need 2 fluorine atoms to accept the 2 valence electron, because 1 fluorine atom can only accept 1 valence electron. 1 fluorine atom is 27, the electronic configuration, so it needs 1 extra electron. So fluorine to 8. Okay, now it's 27. It accepts 1 valence electron from magnesium to become 28. Since it accepts 1 electron, so the charge is 1 negative. Now it needs 2 fluorine atom to accept the 2 valence electron from magnesium. So these fluorine ions would be the same. Okay, because magnesium atom loses 2 electrons, so 1 electron to each fluorine ion. Then you have to draw the legend. Magnesium electron, fluorine electron. Okay, so you have to draw the dot and cross diagram to show such a combination, and then you have to name the atoms and the compound form. So the atoms would be magnesium atom and fluorine atom, and the compound is magnesium fluoride. So the atom is called fluorine atom. Once it becomes an ion, a negative ion, it becomes, instead of fluorine, it becomes fluoride, becomes a negative ion. Now explain why molten ionic compounds will conduct electricity. Solid ionic compound will not conduct electricity. Okay, you have to explain why molten ionic compounds will conduct electricity. Now, when the ionic compound is molten, what happens is, so ionic compound consists of positive and negative ions held together by strong electrostatic forces of attraction. Now, when it is become molten, molten means melted. All these positive and negative ions are free to move about. And when all the ions are free to move about, they can help to carry charges. And when they carry charges, that means they can conduct electricity. Okay, so for part B, this is part A. For part B, you have to say, why does it conduct electricity? Because the positive and negative ion, because in molten ionic compound, I write it in point form again. You have to join all the sentences together to form a paragraph. Molten ionic compound, the positive and negative ions are free to move about, are free to move about to carry charges. Okay, and hence they can conduct electricity. Hence can conduct electricity. Now for solid ionic compound, this would be the structure of a solid ionic compound. The positive and the negative charges are fixed in their position. Okay, the positive and negative charges are in fixed position in the crystal lattice structure because they are all attracted by strong electrostatic forces of attraction. And since the ions are not free to move about, they cannot carry charges and hence cannot conduct electricity. So in solid ionic compounds, the positive and the negative ion, are held together by strong electrostatic attraction force. Okay, they are held together by strong electrostatic attraction force in fixed position. So not free to move about, to carry charges. Hence can't conduct electricity. Okay, so these are all the key points. Solid ionic compound, positive and negative ions are held together by strong electrostatic attraction force in fixed positions, not free to move about to carry charges, hence can't conduct electricity. Okay, this is 2006 paper 3 B9 for the chemical bonding chapter. Now let's look at this question here. Name the type of chemical bond found in a molecule of carbon dioxide. The chemical bond found in a molecule of carbon dioxide, there are only two types of bonds: ionic bond and covalent bond. Covalent bond is the bond formed between non-metals. Carbon dioxide, CO2. So it's a bond between carbon and oxygen. Carbon is a non-metal, oxygen is a non-metal. Therefore, the chemical bond found in a molecule of carbon dioxide is the covalent bond. So the first one is just covalent bond. Now for 2, draw a dot and cross diagram to show the arrangement of electrons in a carbon dioxide molecule. Only the outer electron shells need to be shown. Carbon dioxide is CO2. There is one C2O. Now carbon atom, what is the electronic configuration? So carbon atoms, how many electrons are there? Carbon atoms, the atomic number is 6, so 6 number of protons, and in an atom the number of protons is the same with the number of electrons, so carbon atom has 6 electrons. 6 electrons, the electronic configuration would be 2 4. So the electronic configuration is 2 4. How about oxygen? Oxygen, 8 electrons, electronic configuration is 2 6. Now there is one carbon atom, CO2, one carbon atom, and 2 oxygen atom. This is oxygen, this is oxygen. Now carbon, 2 4. So in order to be stable, it needs to become 2 8. So it needs 4 extra electrons. It needs 4 extra electrons, meaning that it needs to share 4 pairs of electrons. Okay, it needs to share 4 pairs of electrons. So that means it has 2 places to share. So 2 pairs here, 2 pairs here. Remember, every time you share 1 pair of electron, you actually can gain 1 electron. So in order for carbon to gain 4 electrons, it needs to share 4 pairs of electrons. So 2 pairs here, 2 pairs here. So out of 2 pairs of electrons here, that means 4 electrons here. Out of 4 electrons here, 2 must belong to carbon, 2 must belong to oxygen. So you can draw like this. Likewise, it needs to share 2 pairs of electron here. So you can get the legend first. Carbon, electron, oxygen, electron. Okay, so it needs to share 4 pairs of electron. So carbon electrons, it has 1 2 3 4. Oxygen, 1 2, but each oxygen atom there are 6 electrons. There are only 2 electrons here, so 3 4 5 6. Same thing for the oxygen here, only 2 electrons here, 3 4 5 6. And then after that you have to double check for oxygen how many total number of valence electron. It must be 8 because it is stable. 1 2 3 4 5 6 7 8. For carbon also it must have 8 electrons. 1 2 3 4 5 6 7 8. For this oxygen also must have 8 electrons. 1 2 3 4 5 6 7 8. So it's correct. So this is the dot and cross diagram for carbon dioxide. Now substances with the chemical bond found in carbon dioxide normally has a relatively low boiling point. Explain why. Now why does carbon dioxide have low boiling point? Because first of all, it is because of this reason. Okay, covalent substance, simple molecules, and the simple molecules like for example methane here, CH4, they have weak intermolecular forces. Okay, the methane molecules are held by weak van der Waals forces or weak intermolecular forces. Therefore, little energy is needed to overcome the forces, and because of that, it has low boiling point. Okay, so you can just say for part B, so you can just say carbon dioxide exists in simple molecules, and these simple molecules basically is held by weak intermolecular forces. And because the intermolecular forces is weak, little energy is needed to overcome the forces. And because of that, it has low boiling point. Okay, again, these are in point form, so you have to write it in essay format.